Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 431 maximum score of non-overlapping intervals. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one you have to. I think the first idea that I would well, first of all, even before the indexes thing, which honestly I struggled a lot on. I got this in about 36 minutes, but 25 or 30 minutes of that was just me trying to figure out the index part. But let's just focus on a easier problem to solve first, which is to say, just getting the maximum score, right? So the idea behind getting the maximum score is kind of a generalization of a easier problem on Leetcode, right? And the idea behind that, I don't remember. I should try to find it. But we'll explain it anyway. So let's just say that on a easier example, you only have two non-overlapping things, right? And the idea behind using the two non-overlapping thing is also in a way sweep line, right? So there are a number of ways you can implement it, but the way that you do it with two things is that, okay, so now that's the number line. Let's say you have a number of segments and they could be overlapping. There's some weights and score or whatever, right? And then you're just trying to go from left to right, right? Oops. So then the idea here is just that when we go left to right, we just update the best scores that we've seen. So let's say we go here and then we go all the way up to let's just say here, right? Maybe that's okay. Let's just say actually a little bit better. Let's go a little further. Maybe add a little more thingies. But yeah, so then now let's just say you're up to here, right? And what does that mean? As this is the sweep line. This means that we process all the endpoints already of the previous things, and then here we get to choose, right? We're processing this segment. We're saying that, okay, this segment and one previous segment, what would be the best segment to take? And here, keeping in mind that we're looking at all the weights of everything in before. Not this one, because this one hasn't finished processing yet, but all the weights before. And as a result, in this case, for a case of two things, we have an easy thing to choose, right? Because we have all these different weights. And you just choose the one with the highest weight, right? So, and that of course is a Leetcode problem. It is something, I don't know, you have to search for it, or someone please leave it in the comments. But, that obviously having foundation on that problem is strong for this one, right? Yeah. So let's say you really understand that one, and I think I have a good video on it. So I'll try to find it and put it in the comments, or if I forget, please remind me, or someone put it in the comments, right? But yeah, so that's the case for when there are two segments, right? So what happens when you have, say, three segments? And we'll get to four. Four is easy to generalize when you understand three, which is that, okay, so let's say you have these things. But yeah, so then now you don't look at just one number anymore. You could generalize it in two cases, right? So now let's say we have the same thing, and there's no way for me to undo enough to erase these things apparently. So I'll just use another color. So you look at all these, and then you go, okay, well, there are two possibilities, right? One is that we have a best answer for one segment, and then best answer for two segment, and this is where the dynamic programming comes in, right? So here we're processing this segment still. Then now we look at so we can take 0 segments, right? And then now we update it for new best for 1, right? So this goes up. So 0 plus W, right? So 0, which is I guess just W, best for 1, or and I'll try to do another color, or you could do the best for 1, add that to the W that we're processing now, because then now, and then compared to the best for 2, so then now we have the new best for 2, right? Possibly, maybe, right? Of course, it's only new depending on how you compare. So that's basically the idea, and of course, hopefully that makes sense, right? These are kind of like dynamic programming states, if you will, and yeah. And then the idea behind that then now is that if you want to extend it for 3, hopefully, this is for 2 segments, right? For 1 segment, And then for 3, then it just becomes straightforward of, okay, well, you have the best for 2. So then now new best for 3, right? And also best for 3, I suppose, is how you add it, right? So plus W. And that's basically the core idea behind this. So, and you can extend it for 4. I ran out of room, obviously. I'm way bad at scaling my my drawing, but you get the idea for 4, hopefully, right? And we'll go over the code, you'll see it there. So then the other tricky part is is that we don't actually return just the score, even though the prompt does say maximum score. You actually want the sequence of the maximum score. And this is the part that I struggled for about half an hour. The other part I actually got relatively quickly, frankly. And you could watch the live portion and you see that I mostly got it quickly. I think maybe I had some typos and I had to debug a little bit, but yeah. Otherwise, I think I was happy with that because I thought that the other part would be easy. I was wrong. Or at least for me. Because the idea behind that would be to, my initial idea was to do some kind of path reconstruction. It's very common. So, you have the best, you try to do path reconstruction. And I couldn't figure out how to do it, frankly, for some reason. And if you do know how to do it, let me know in the comments. Maybe I just need to think about it more. But as I was playing around with it, and you should watch the live portion to see how I play around with it, maybe that's the interesting part about this video, because look, anyone can give you the solution. Anyone can read off ChatGPT or the discussion board and pretend that they're smart. But, and I don't think I'm smart, but if you're here and you want to see how I struggle, how I come up with the solution is more interesting than the solution itself, if you ask me, right? And I kind of play around with different things, and you'll see me trying a few different things with path reconstruction. But it turns out that one thing that you have to abuse a little bit is that n is equal to 4, right? Or the max n is 4, so technically there are 5 states. But as a result, you can actually just store the path, the entire path. And what I mean by that is that we look at this thing and we just do comparison. We can also, we do a new best for sure, right? But we can also just store the path as a tiebreaker. So that means that if the score, the rate, the sum of the rates are the same, we just compare with path. And in general, this is a really bad idea because the paths can be really big, but because paths can only go up to 5, then it becomes this idea of that, okay, because you only worry about storage, it's going to be n, so n times, we store one thing for 1, 2, 3, oh, sorry, this is plus, 4 plus 5, maybe 4 actually only, so this is only really up to 15, right, or give or take. So even though the constants matter, and technically I guess you can say this is d squared, where d is the biggest number of overlaps, right? But d being 4 or 5 distinct ones of whatever, it'll be fast enough. And that's really the idea behind this, which I kind of missed a little bit. It took me a while to figure that out, frankly. Because I guess in a way I never thought about it, because it's just something that you almost never do, because d's in this case are never small enough for d squared to be fast, even though, because the rest of it is n times d, which is fast, or at least it scales way better, right? Because n is 10 to the, or 5 times 10, or 50,000, right? So even if d is 10 or even 20, you're good, but d squared is 400 and 400, it's getting big, it's getting chunky, right? So that's really, so I just never thought about it, and it took me a long time because it's just one of those things that, like, it's kind of funny because as a beginner, maybe you do it because you didn't know any better. And you have experience, you almost never think of it because you're just like, oh, this would never work. But I just never thought about it. And it may be the first time that I've done this intentionally in a long, long time. Like, I don't remember the last time I used this. But in any case, yeah, there are a couple of things in terms of the actual implementation, but but we'll go over the implementation. It's a little bit ugly, but it's fine. But I have two type of events. One is the in events and out events. I just kind of did this way for, I don't know. But the in events is, if you remember the intervals, we have the left side of the events and the right side of the events. And maybe you could call them left events and right events. But naming things is hard for me, especially during contests. So I just do the first thing that comes to my mind, honestly. And I put in events as in we in, right? So here we have to keep track of, the other thing, and these doesn't have to be in any order. It just has to be grouped by the left index, right? So that we can make sure that we process all the else at the same time. And and that's it, right? Which is that we keep track of the out event, and then the rate, and then the index. Basically everything that's in the input, really, but we just kind of group them by the left index. And then here we have the out event setup. We have the best, and remember this is only up to 4, but you have 0, 1, 2, 3, 4, so that's 5 elements. And then we have the previous thing, also, but yeah, and then this is, we set the best is equal to 0, just so that, I don't know, it's just easier to track these things. So I think ultimately I didn't need it. It's just easier for me to debug because the output is a little bit cleaner. But yeah, here we have all the sorted things of left events, and maybe I could rewrite this as process, right? So maybe I should have done this during the contest, but yeah, process out, and then we have right, and then we can just put this there. And the idea here is just process the out event. It is what it sounds like, right? So then here we process out L, and keeping in mind that if this is, we pop it off the heap because it just takes a small element and then we process that. We'll talk about the type breaking in a second, but it has to be exactly less than, because if they are exactly the same, they technically overlap with this problem, right? So then here, and I'll come back to the process out, but I just want to do the process the inside first. And the reason why I want to do that is that for here we also process out after the last element. So process out at infinity, say, so that it is a little bit, that's a little bit cleaner, right? Did I do something weird? This is why I always try to at least test stuff. Okay. Oh, this is, I'm being dumb. This is L. Okay, yeah. It just so happens that it was very fortunate that it worked with the other thing. I am very silly boy. Okay, let's give it a submit just to make sure that I'm not lying to you. Okay. But yeah, let's look at now that it's a little bit cleaner. You can see that this function is now only for processing previous, and I wrote it this way because I thought I was trying different things, but you think about it from the order actually here doesn't matter as much, right? And the reason is just because, right? But basically here, when we process the left side of things, keeping in mind that we don't update the best until the outs, because for future to be processed. So here, this is where we basically process the in event so that you process the right side of the segment. And the right side of the segment is just updating the best idea, right? And then now for each item in this in event, we go, okay, well for I, and I is just, I is the number of segments seen or used, maybe? Used, right? So with I 0, that means that we want to look at because best of 0 is equal to the best score where 0 previous segments were used. And then, same thing, but then 1 is going to be where 1 previous segment was used, and so forth, right? ... So then here, so then now we want to say for example, if I is equal to 1, the best score where 1 previous segment was used, then now we want to consider adding the current segment. So then now this becomes I plus 1, right? And these all becomes out events. and we also returned yeah, so this is the new W score, right? This is the index, and here is this normalized tuple, this really ugly thing. But what it does is just that it looks at the previous best, the tiebreaker for the path, right? So this is actually the path. It's not order dependent, but it is the path. The path that gets us to best of I. So then previous of I is the path that gets us to best of I. So then now we want to add index to it. But we also want to keep it sorted and make it a tuple just so that it, I don't know, I just like to make things tuple just in case I need to do other, so that we make sure that it doesn't get changed, right? As a const by accident or whatever. So yeah, so that's basically the idea, and we keep it sorted so that, because that's the criteria that we need to do for this problem, right? And that's basically it, right? So that's the in events, and then for out events, we process it on L and infinity at the very end, and then here oh, I actually didn't talk about this one, but basically we just push the right side, the out event, on the heap so that we know to process it on the heap in order, right? And then now when we process it, we take it off the heap, and then make sure that for an L, which is the left boundary or whatever that we want to process up to, but not including, so we just pop, and this is the right side, and then we process the out event, given these four things, which is the number of segment used, which is B, NW, which is new weights, new best weights, and then we have the index of the element that we're processing right now, and then T is just the answer tie-breaking key, right? Which can have almost 5 elements. So okay, so if the new W is better than the previous best, then we just update it, and also update the previous thing to the tuple. If it's equal, but T is smaller, meaning it's lexicographically earlier, then we update previous as well, or we just update previous because best is going to be the same. And then we just remove all. We remove all the events. I don't think you technically need to, but just in case I had some weirdness, then we don't process the same. Like even if we do the same thing more than once, this would be a no op or a very cheap op. It'll be like a spin lock, I guess. But yeah, so that's basically the idea for this one. And yeah, and then at the very end, we just double check all these things, because strangely, even if you look at the example 1, which, as we know, 2 is actually, that's the best answer for 2, but there's actually, you want to force 3, you can still calculate it, and it would take 7. I mean, the maximum score is 7, which is not as long, but but yeah, and it'll be 2, 3, and so forth. So if you need to force 4 segments, the score is lower, but but yeah, so that's why I did this is just a loop to get the best score, and this is the tiebreaker that you want, right? Which is the best score, or if the score is equal, then we just look at the lexicographically smallest thing, and that's it. That's all I have for this one. Yeah, what's the complexity here, right? Well, for each element, we create 1 in event, and at most 5 out or 4 out events, right? 1 for each segment. So that's going to be 4 times n. But there is, of course, sorting here. So there's only 1 sorting. It's not, the loop doesn't matter with sorting. So this is 4 times n, or d times n, if you want to call it that, times or plus n log n, right? So yeah, so let me write this down actually. Is equal to O of d times n plus n log n, right? And space complexity, as we talked about, because actually, I lied on the time complexity, didn't I? Huh? Because for each element, because okay, even for here, right? Technically, this is O of d time, right? To create this tuple. I mean, okay, there's actually some sorting on D, but okay, you can do a linear sort. So whatever, pretend that this is O of n for now, or O of d for now. That means that for each thing, it is going to be d squared, as we talked about, right? So I lied a little bit. This is actually O of d squared times n, and that's actually also space as well, because you have to store the thing that you calculated in time, right? So that's basically the idea for this one. Yeah, it's hard to get the time complexity better than the space complexity because you have to allocate the space, right? So it's always going to be this way. Yeah, but keeping in mind that d is equal to 4, this is why this is fast enough. And yeah, that's all I have for this one. Let's go over, let's look at the code one more time. These are to set up the events. This is to processing the in event. And then make sure that we process the out first. And then at the end, we also want to process everything in the heap. And then just find the best. And that's it. Yeah, that's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you could watch me solve it live during the contest next. Okay. Now we're in business. 30 people solved it. I've solved Q4. Let's see what's the leaderboard doing. Okay, so a bunch of people already got everything. 348. That's not great. But this leaderboard looks weird, so I don't know. Okay, let's solve. Huh. Whew, okay, so we have intervals, we have weights, we have intervals again. Weight. 4 non-overlapping intervals. The score of the chosen the total sum of their weights. Intervals with 2 and 3. Oh, at most 4, so it doesn't have to be 4. I see, that's why I was wondering. Oh, there's only 2 things. They should have example 1 as like the really basic example, like this one, but oh, whatever, it's not a big deal. Okay. I don't know this one yet in case you're wondering, but okay, so 4 intervals, you have to choose that so they may overlap, but you do not choose them. And more importantly, you need to keep track of the indexes, which is fine. Is it not just DP? I don't get it. I'm actually honestly a little confused. Because then they don't overlap anyway, so yeah. Yeah, it should be just DP, right? I don't get why this is hard. Okay, maybe I'm just confused, which is also true. Okay, so here we have we want to sort by the left side. Okay, fine. Okay. Yeah, okay, yeah. Up to 4, but that's fine. We have to also keep track of these things, but let's at least get the right answer first, and or right without the return value. So I think maybe implementation right, this is annoying, but that should be fine, right? So we want to say we want to sort by the left side, which is fine because then we just set up things for the right side, right? So then now we have, let's just say best is equal to 0 times 4 or something, right? Or 5 maybe. And then now, right? So here for I in range of 5, or maybe just C is equal to 5. Right, so then now I like to say events, oops, put my finger as well. Well, it's really just no, this is how I want to do it. List, right? Don't, whatever, but okay, fine. Okay, yeah. So then events. Oh, I need to do 2 layers, that's why. No, that's fine. We actually don't. Okay, so then now we have best of this, right? So here, best of. So, okay, we have to update best at events, right? So events of right, we want to append I for I we have weight plus best of I, or I plus 1, we want to do this, right? So from 0, yeah, I think that's right. Right? And then now for if all in defense, I guess technically if do they overlap if they do not? Okay, yeah. Then now afterwards we update. Okay, so then defense sub R, right? So for I don't know, B new weight and defense sub R, best of B is equal to max best of B new W, right? I don't know. I don't know why this is hard though. Okay, so then now return max of best. I guess if this is 5, then it goes up to 4, so actually technically C minus 1, right? And I guess that's it. I mean, this will give me a type error probably, but whatever. I just wanted to, okay, so 5, 8, 10, 12. That doesn't seem right. 8 is right for 2 elements, but why do I have 12? Maybe I'm misunderstanding something. It's possible. Oh, because all this parsing is whatever, so I have to do all the else together first. Okay, because of the overlapping thing. Okay, fine. Let's just say this is okay, and then now yeah, okay. I mean, that sounds right. But we have to be a little bit careful. I mean, okay, yeah, that's right, fine. But then now we have to do a heap, I suppose. Yeah, we have to do a heap for the out defense. So we have to do something like this, right? And then while length of heap is greater than 0 and the biggest element, the smallest element rather, it is less than L, then we want to do our defense process. Right, so now we can do this. And then yeah, and then we just do this other thing. Oh, and then here we have to make sure that if R is not in scene, then H. Right, something like that. What line is that? 9? How did I just? Oh, I took out the in and intervals. Okay. 27 heap Q. I have to pop, don't I? Okay, 5666 is way wrong. Why? Oh, because we don't do the while length. I have to do this thing one more time. Okay, that's not it. Okay, so 1, there's nothing to it, of course. And then at 4, we process the 3. I mean, we have plenty of time, I think. Okay, we processed the 3. Also, we have to write. I mean, it doesn't do anything, but oh, actually, it does do stuff. I'm actually that is pretty bad, actually. So it's good that I would have ate a timeout for no reason, because I even set up for it. But okay, so at 4 we processed the 3, which is fine. Okay, and then at 6 we processed the 5. So 1 to the 5. Okay, and then 1, 3, 4, 5 maybe. No, that's 4, so that wouldn't work. Okay, so 1 to 5 is 5. Okay, and then what? And then just stop updating. Where's that? Index 3 is 2 and 3. Oh no, 2 and 3 is these two. Okay, so I misunderstood it actually. Okay, so at 6. Okay, so at 6 we set it up so that also let's, for the sake of reading, we can do arguments R is equal to, right? And we just delete, it's fine. Right, so then at 6 it sets up for 9, should be 8, right? So yeah, 2, 8. So then why is it not doing 8? We don't process. Well, maybe we do, but I just don't print it. No, we don't process. Why don't we process the rest? Is this the else statement? Huh? It's really wonky. 8 at 8, only 9 is on the heap, and then maybe we want to say print best, but also the heap. The heap has 9. Oh, I'm dumb. I just copy and paste. This is what happens when you copy and paste. Whoops. And also click on one bunch. Okay. So then now we have 5888, and then 4, and then 21. 7, 6 is 13. Okay, so I think this is right. Now that this is what happens when you copy and paste. You're just stupid. I mean, when you don't think. Okay, so then now this gives us the right answer-ish. We have to figure out how to keep track of it, right? Especially with this lexicographically smaller one. If the first, okay, so you want the lexicographically smaller one is annoying. 77 people got it already. Jeez. I mean, this isn't too hard. I'm not that surprised, but I am very slow though. Okay, how do I write this in a good way? Okay, so here we have the best. Where's the best? So this thing, if best of b is greater than w, we want to optimize for index if it's equal, right? So here, if it's, we have to make sure to do here and fix that. Okay, then now we do, so we didn't even need it really, because we have to do it this way anyway. But then also previous of b is equal to out event. Out event needs the index. Our index gets the from index, so we need whatever, and then here we have index on the in event, and then out event with the index, and then where's my out event things? The two things. Let's just add an assert for, so I remember to edit this. Where's my out event things? Oh, okay, here, index. Okay, else if best b is equals to num and index is smaller than previous b, then previous b is equal to index, right? I mean, that's it. I think this part I can copy and paste, I think. Double check though, Larry. Okay, and then now here, let's print out previous. Why not? Oopsie daisies. Okay, that's no bueno. Why is that? We always should set it. Fmax. That's because I'm dumb. Of course, this would be the case. Also, best max we just set to -1. Maybe that's a little bit cleaner. Those zeros should be okay too, honestly. But oh, because it adds the 0, so actually we do need this to be 0. Well, the best of 0 should be 0 anyway. Okay. And then now we're 4-1, right? This is actually odd. 1831. Zero, 1, 2, 0. Oh, I see. That's actually a good thing because I would not have caught it. Yeah, because that's actually pretty bad. No, that shouldn't matter, right? Yeah, it still shouldn't matter. What does this mean? This means that I mean everything is very wrong actually. 1 and 4 is definitely not the index, right? Index we want it to be smaller. I mean, I think it doesn't matter that we changed it, but so 1 and 4. Why does it think 1 and 4? 8 is 4 index, 4, 6, 7. So 7 lexicographically smaller, but 1 and 4. 1 and 4 is definitely not right because it's a rate of 3. Best of I, yeah, I mean, I think this feels right. Huh. Why? previous as you go to the new way. I don't know. Okay, let's just print things out then. Okay, so then now this is 0 index, which makes sense. Okay, 1, which also... No, that doesn't make sense. Did I sort something? No, this is on the thing. Oh, I do sort first, that's why. And I don't even need sort anymore. Okay, so I'm just being dumb. I don't even need to sort anymore. Okay, okay. So 1, 3, 3, 5 is wrong, but at least it's closer maybe. 5 and 8 is also very wrong. Because there's no even... Oh no, I'm looking at the wrong index. So it's 2 and 3. 2 and 3 is right. So we're good. 1, 3, 3, 5 is very wrong though. It's because... Okay, because this index... 21 is right, right? 13, 16, 21. What's 1, 3, 3, 5? 1, 3, well, 3, but 5. That doesn't make sense, does it? Okay, let's look. Okay, so then now we update with 5, which is index 6. So 1, 2, 3, 4, 5, 6. So this is the first thing parsed at 6. That makes sense. Okay. I should not update it this way. I think that's why. But also that means that, oh, that's hard maybe, because we have to tie break. Because, oh no. Because we're tie breaking not on the sort. Oh, maybe this is harder than I realized. But this is 6. And also, I mean, I shouldn't be duplicating it like this. I was just a little bit lazy. That's fine. I mean, we can fix that, but this should be a 6. I don't know why this previous is a 1 actually. So I update something wrong here. I definitely update something wrong here. I mean, that's actually tricky. I don't know how necessary to do this, but okay. Now you know the numbers, so then okay, so let's say we have the deltas. So then we have the deltas and then we just sort by them. No, that's not enough, right? You need, because you need the ones that don't give you issues. Huh. Because it's not enough to just look at all the length and then just take any 4. So this updating makes sense. All these updating makes sense. But because even if I had this one, then this is just 7 plus 5, but then we update 5, right? So some of this is very wrong. How do I do this one? I don't know that I know how to. I didn't think that this would be the hard part, honestly. That's why. But especially when you have tie-breaking things. I don't know how to incorporate all this tie-breaking things. I thought I could do it that way, but the way that I did it, but that's not right at all, right? because you have to somehow have this 5, which gets incorporated here, but then we don't keep track of the previous in that way. Is it enough to always be greedy on the thing? Also, yeah, I don't know. Maybe it is good enough. Because here there's 1, 3, 6, 5, 5, 6 in some way, and we've been greedy about it, but I'm not keeping track of the correct previous, right? Maybe I could just keep track of the previous of the index. Yeah, maybe I could do that. Let's see. Right, instead of being like this, then I could do do I not have n? I guess I need n. And then now previous. Well, previous of index would be index, but that's just dumb, right? So what would that be of? Man, I am not smart today. How do I take it out? I guess it could just have 2 numbers, right? Okay, let's just say that. So previous. Maybe that's a little bit better. I don't know. All right. So then now, if it's greater than, then right. So then that would just be. So now we update, but we don't want to update until. How do I do it? Maybe we need to do better here too, honestly, but how do I do it? And this is no longer true, right? Okay, so this is in the set. This is just whatever, none. No, let's just do okay. Well, maybe I don't need this then. Okay, maybe something like this. I really need to put this in a function, but let's see if that works first. Okay. 1356 0234. That's definitely not right. So 0. Okay. The 5. This replaces it, so it actually should be not this. It should be previous. Right? But I think that there's some like weird order of things here. Like, can you even add 0 to this? I guess. Two, 4. What's 2, 4? 2. And is 2, 4 the right answer? No, it's 2, 3. So this is just very wrong. So this is right, which is happy. 1, 3, 1, 2, 5, 6. Actually, this is still wrong, but mostly because it passes to 3. So 1, 2, 3 at the end, right? How does it process to 0 though? 2, 3. Okay, so need better about this thing. Okay, I don't know that this is good. It's slightly better. Oh, it just does crazy things. Okay. 2, 3, 4 is way wrong. Why does it think that? I think you just need to put the tuple inside this, Larry, instead. Okay, fine. Okay. Then it is going to be, yeah, that makes sense. Previous sub I plus this thing plus this craziness. Okay, so then now we have this and the T. Okay, I think now we're in business. I said it a few times though, so I don't know. We'll see if my business is a sad business. Tuples to tuple. Previous sub I. Oh, I guess I had a list here. Okay, now we're good. I mean, this is wrong, but that's because this has actually worse answers. So okay, so we're good. Which is that? Okay. Okay. C or C++. Now let's see. Press of p index is greater than press of we have to be the other way around, then p index is equal to I. No. Oh, this is the other one is right, but here we want this. I actually don't need this to be a tuple, but I think the reason why I have it so that I don't do anything silly with it. YOLO. Wouldn't be surprised if this is okay. Well, okay, I'm a little bit surprised that this is right, but I am happy that it is right, of course. How many people got it? 177. I don't think that I'm that fast. I think the idea was that I was a little bit slow in just doing it this way. I think I was too much on the path of reconstruction. Was this the best so far with that as the answer? I think I was. Yeah, I mean that's pretty way it. I think I was just focused on the wrong thing for this one, from years of experience kind of thing. Like, thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, the explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.